So in this video, we're going to go through an implementation of an AI agent. Specifically, we're going to go really deep dive into how AI agents are implemented and some advanced techniques into implementing AI agents, which we are ourselves using inside FlowHunt to create really deep advanced AI agents that actually create other sub-agents in our own tech stack. So in this video, we're going to go through, this is a multi-series series of creating and implementing AI agents. In this video, we're going to deep dive into planning for AI agents. So stay tuned. So in this video, we're going to go through planning of AI agents. I'm going to go through basically just the planning aspect, but this is from LangGraph. So you can get this course from LangGraph. If you just type in LangGraph deep research agents, you would find out basically this GitHub repository. I'm just going to go through and explain it in my own words how this works. So basically planning, why do we even need planning for AI agents? That's the first problem. And that leads us to context rot. So this is a paper released by Chroma. Shout out to Chroma. They have a really good, they release very good papers every now and then. And they went through the problem of basically LLMs trying to find out data from a huge token context length. So usually with AI agents, they need to they need to process like 10,000 tokens, and it should be assumed that they would do the same in 100 and 10,000 token, but in practice they have a lower accuracy when they reach the 10,000 token limit. And the current before this paper, the evaluations that were done, specifically needle in the haystack, all the models are reaching 100% accuracy on that. So we didn't have a really good evaluation, and the Chroma team came up with this idea of creating a better evaluation, which introduces distractors in the paper. So if you have like a document and you have a needle, previously the evaluations worked so that they asked something about the needle in the whole corpus of the text that is in there. But now this paper actually introduced distractors. So distractors are a small paragraph that is about the needle, but it doesn't answer the same question that will be asked from LLM. And this paper went through and they did a really deep research on the accuracy, and the final result is that it actually confirmed their hypothesis that why in practice basically this happens. Well, not actually why, but it actually confirmed the hypothesis. And you see this accuracy graph of each different models that after about 10 to the power of 4 tokens, then they have a really lower accuracy. And something also really interesting about this is that Claude does a better job than all the other AI agents or all the other LLMs out there. So Claude 4.5 actually has better accuracy in all different distractors. But back to the deep AI agent, I'm going to just go through the code, how it's written, and maybe it gives you some ideas of how to create your own AI agents. So how to actually solve this problem of low accuracy in high amount of token, it's with planning. So it's like giving the AI agent a piece of sheet so that it can write down the plan and cross off the plan or the small steps in the plan as it goes through the whole process. So in LangGraph, this is the implementation in LangGraph, and I'm going to go through the code line by line just to make sure that we understand everything. Basically in LangGraph, it's a state machine. So you have the AI agents, and in the whole process of the AI agent, you have a state. So if I want to show you the graph just real quick, it will look like this. So you have a start point and an end point. From the start point, you go to an AI agent that connects to a tool. So it recursively calls that tool. And then at some point, the AI agent decides, okay, I'm done. And the end result or the end output will be outputted to the user. So this is the whole graph of an AI agent. And within this loop that it's doing, there is a state that is going on. So we call it deep agent state. That's just in the code. And there is to-dos and files. So in this video, I'm just going to go through the to-dos, but check out the next video about the files. But to-dos is basically just a list of to-do. So that's just a data structure. As you can see, each to-do has a content, which is basically the short description of what is the process, what is the small process that the AI agent is trying to solve, and each state of of each point or each bullet point in the to-do. You'll probably be familiar with this if you're using Cloud Code. And then you have a file reducer, or specifically just a reducer that you will see in here. So we're gonna give two tools to the AI agent: read to-dos and write to-dos. So read to-dos, it will just see the to-dos, that is a list, and it will just print it out in a nice way for the AI agent. You see, based on the status of the to-do. But the write to-do needs to use like a reducer. So that's just another concept in LangGraph. A reducer just makes it possible that in multiple threads of calling tools, it just basically orchestrates really nicely the data structure that you're having. But overall, just write to-dos, it just updates the to-do when the AI agent wants to update one row in the to-do. And yeah, that's all. So this is a prompt that's going to use. So use the write to-do list to create to-do as a starter, and after you accomplish a to-do, use read to-dos to read the to-dos and reflect on what's going on and so on. And then we also give some other extra tools to the AI agent, so like the web search. And yeah, you see here the full list of tools that is given. So just a web search, write to do, and read to do. And for example, this is an example run that is given. So give me a short summary of MCP, Model Context Protocol. If you want to know more about MCP, what is it? Just click on the link below in the description. So first, the AI agent goes through a loop. It first tries to write a to-do. So it writes a to-do of what are the steps that it is going to do. And hopefully you will see here, so it writes a to-do list of the description of what it's going to do. So it search for information about Model Context Protocol. And then it does the web search tool to do a call, and then it reads the to-do. This is, as you can see, it's in pending mode. And then it writes the to-do to update the row, and it updates it as completed status. And then it gives out the output to the user. So this is just a simple example, but in really complex scenarios, you would need to care about how these to-dos work.